Bavaria, October 1944. At the Rechlin Test Center, senior engineer France Hartman stood in a cold hangar and faced the captured fighter. A North American P-51 Mustang. Forced down 3 days earlier, the pilot was now a prisoner. The airplane was almost undamaged. That made it priceless. For months, Luftwaffe pilots had reported a silver escort that seemed to have no limits. It reached Berlin. It chased them home. It fought at altitude and at low level. It outlasted everything. Some called it the executioner. Hartman had treated those claims with caution. In combat, fear inflates numbers. But the losses were real. Experienced men were vanishing from the roster. Something had changed. He was not a soldier. He was an engineer. 38 years old. Daimler-Benz trained. A man of equations and tolerances. He had met British and American engineers before the war. Conferences. Talks on superchargers, compression ratios, and fuels. He believed in what worked, not in slogans. His job at Rechlin was clear. Examine enemy aircraft, identify strengths, find weaknesses, suggest tactics. He had studied Spitfires, Hurricanes, P-47 Thunderbolts, B-17 Flying Fortresses, and B-24 Liberators. Useful lessons, yes. But nothing had prepared him for this moment. He circled the Mustang with a notebook, sleek lines, a laminar flow wing, a bubble canopy with superb visibility, clean riveting, no crude repairs, no substitutions. This was not a desperate airplane. It was a refined one. The cockpit told the same story. Instruments clear and logical. Radios modern. Oxygen system robust. Everything felt designed for the pilot to fight, to survive, and to return. The truth, however, would sit under the skin. He and 2 assistants removed the cowling, bolt by bolt, panel by panel. He thought through the options. The performance hinted at a power plant of at least 1,500 horsepower. Maybe more. The silhouette ruled out a big radial. It must be a liquid-cooled V12. The kind he knew well. The last panel came free. A V12 engine. A 2-stage, 2-speed supercharger. Exactly the architecture he expected. Almost familiar. He leaned closer. Casting marks. Fastener heads. Subtle differences in layout. Then a stamp on the block stopped him. Packard Motor Car Company. Detroit, Michigan. United States of America. He stared at the words. Then looked again. He knew that design. He had studied photographs of the Rolls-Royce Merlin in journals before the war. The British 512 that powered the Spitfire and the Hurricane. But here was a Merlin, built in America by Packard. An automobile company. His assistant whispered the obvious. The British had shared their crown jewel. The Americans had built it in quantity and in quality. They began a methodical inspection. Fit and finish were superb. Tolerances were tight. Components were clearly made for interchangeability. Parts from one engine would fit another without handwork. Hartman saw consistent alloy use. Precision gears in the supercharger drive. Clean castings. Thread forms matched. Even the safety wire work spoke of training and discipline. He requested files, production notes, intelligence reports on Packard and Merlin supply. The numbers arrived and pressed down like weight. Packard had taken the British drawings in 1940 and adapted them to American tooling and gauges. They standardized on American thread forms. They converted hand-fitted parts into true interchangeable assemblies. They set up jigs. They built gauges. They trained thousands. Output rose from hundreds to thousands per month. By late 1944, Packard was producing around 2,000 Merlin engines each month. A single company. Meanwhile, German engine plants of all types struggled to reach that figure across every model combined. Allied bombing raids forced move after move. Skilled workers were conscripted. Metals were substituted. Bearings suffered. Time between overhauls shrank. The technical details mattered. The Packard Merlin's two-stage, two-speed supercharger kept power at altitude. It breathed well above 20,000 feet. Radiator ducting used ram air and the Meredith effect to recover some thrust. The airframe carried large internal fuel and could hang drop tanks under the wings. High-octane aviation fuel let the engine run higher boost without detonation. The result was range. Real range. Hartman understood now why the escorts did not turn back. The Mustang could fight to Berlin and fight back home. He compared service expectations. British and American manuals accepted engine lives of 200 hours or more between major work, if handled correctly. German records in late war conditions often showed half that, and sometimes worse. The reason was not incompetence. It was attrition and scarcity. Aluminum alloys were rationed. High-grade steels were scarce. Synthetic fuel lowered margins. Standardization suffered. He took notes on cockpit ergonomics. The Mustang helped its pilot. Clear radios. Good heating. Good canopy seal. Simple fuel system selections for long endurance. A pilot who was comfortable fought longer. He flew better. He lived. Then he widened the view. One engine family, built in 2 countries, powered many aircraft. Spitfires, Mosquitoes, Lancasters, Mustangs, Navy aircraft in smaller numbers. The economies of scale were enormous. Tooling paid for itself. Training paid for itself. Spares flowed. He wrote a report. It ran to dozens of pages. The first pages covered measurements, materials, supercharger maps, and fuel requirements. Then came the strategic section. Britain had trusted the United States with its best engine. The United States had responded with mass production discipline. Together they had created a system. Design in one place, manufacture in another. Upgrade across both. Ship anywhere. Fit everywhere. He contrasted this with the Axis. Germany guarded secrets even from allies. Italy worked on its own engines. Japan pursued separate solutions. Little was standardized across borders. Even within Germany, multiple factories built multiple types in small series. Interchangeability faltered. Logistics frayed. He added the production picture he could verify. North American aviation was producing hundreds of P-51 aircraft each month by late 1944. Total P-51 production would rise above 15,000. Packard Merlin totals would pass 50,000. Rolls-Royce Merlin production in Britain added many tens of thousands more. The combined Merlin family would exceed 150,000 units by the end. Allied aircraft production across the war would reach several 100,000 machines. German combat aircraft totals were a fraction of that. He sent the report to Berlin. He waited. The official reply was brief. Received, filed. Continue current procedures. Unofficially, he heard the reaction. Anger. Dismissal. Faith in jet fighters to overturn the odds. Me-262. Miracle weapons. He knew the pattern. Inconvenient evidence met ideology. Ideology won. Reality waited. Weeks passed. The sky confirmed his analysis. Mustangs arrived in greater numbers. Escorts ranged deeper. German fighter losses grew. Training hours for replacements fell. Fuel was rationed. Bombing damage erased months of work overnight. Jet fighters reached units, but too few, too late. with too little fuel and too little pilot time. For every German jet, there were scores of Allied fighters. After the war, American technical officers questioned him. "Did one engine convince you the war was lost?" they asked. He answered carefully. One engine showed him a partnership. British engineering and American industry working as one. The Merlin in the Mustang was proof of trust turned into power. They showed him fuller numbers. Merlin totals higher than he had estimated. Aircraft totals higher. He nodded. The trend had been clear, even if his figures had been cautious. Why did their partnership work? They asked. He paused. Because they trusted each other. The British gave the Americans their best. The Americans respected that gift and improved the process. They standardized, they shared, they multiplied their strength. Germany trusted no one, so Germany fought alone. The Mustang story is not only about speed or agility, it is about a decision in 1940, when Britain stood in danger and reached across the ocean. It is about a car company in Detroit that took a hand-built masterpiece and made it an industrial product without losing its soul. It is about fuel supplies, machine tools, and shift work. It is about manuals that match parts anywhere in the world. It is about a pilot who finds the fuel selector where he expects it, and a mechanic who can replace a supercharger impeller with a part from a crate that fits the first time. Hartman had stood in a cold hangar and read a nameplate. Packard Motor Car Company. That plate carried more than an origin. It carried a message. The Allies had chosen cooperation as a weapon. They had wielded it with method and patience. Numbers followed. Aircraft followed. Air superiority followed. The war, he realized, had been decided in drawing offices, machine shops, and factories long before most pilots ever saw a Mustang's shadow cross their airfield.